Hey folks, this is Mark at Titus. Today we're going to take a look at something that we promised you about a year ago that we were going to do, and we never got around to it because of just a lot of things happening last year that we never got around to working on our own car. So we had put out a video about this time last year of things that we were going to do last year as far as building our supercharger engine for our in-house car. But due to not being able to get some of the parts, and then by the time we did get the parts, we were too overbooked with work in the shop in order to be able to work on our own stuff. We never got around to it. So we're finally getting a chance to do a little bit of work on this. So what I'm going to do is show you a little bit about the layout of the block and tell you a little bit about what we're doing. Okay, this is the block that we're going to use for our supercharger engine. We actually had this block on display at PRI, and we've showed a couple pictures of it, but I'll just tell you a little bit about what it is. So this is our standard 9/7 deck casting, and what we did is we welded up the water holes in the top of the block to make it a dry deck, and then we built a 1/2-inch deck plate on top of it. And what that does, that gives us a 10, this deck height is actually 10 1.75, so it's a little tiny bit shorter than 10-200. But as you can see, there's our piston. We've got the piston up near the, rotate the crank around a little bit. We've got it up near the top of the deck. It's down in the hole just a bit, which is what we want to get our compression ratio right for being supercharged. But the main reason that we did this, we have built the 500 cubic inch engines, which is a 4.5-inch stroke and a 4/200 bore. We've built that on the standard 9.7 deck. But what I wanted to do for the supercharged application or any of the power adder applications, I wanted to go a different route. And we've been talking about this for quite some time. And so here's one to actually show you. So what we're doing is, I'm in the process of doing a little bit of clearancing and everything on the bottom of the block. Let me catch my piston here before it falls out. So here's where we have to notch the bottom of the cylinder for an aluminum rod. And that is so that the aluminum rod, the beam, will swing not catch the beam. And let me try to do this with one hand. I'll try to actually use the piston to turn the crank, and there we go. And as you can see there's the beam of the rod. And that's why we have to notch the sides of the cylinders. But here is what I was shooting for when I kind of laid this out, is this piston rod. As you can see, this is a pretty tall piston. So with our naturally aspirated 500-inch engine, which had the 4.5-inch stroke in it, the piston pin was pretty high up into the top of the piston. So let me turn this around and hold it to where it's right side up. This piston has a compression height of 1.275, so it's even a taller compression height than our standard street engines and things like that. But what I was looking for was to get a long skirt on this piston to give it stability in the bore, especially in, and this is what we were looking for, and I think we actually got it. Let me put this back in. Get this guy up in here with my one-handed. And I'm gonna have to set the phone down for 1 sec. Okay, so there's what we're shooting for, is that when this piston goes to bottom dead center, even though I have notched the bottom of the cylinder, the whole skirt of the piston, the pin, everything you can see is well with up inside of the bore. So this piston doesn't have any hangout at bottom dead center. Now we've seen a couple other builds using our block where the rod got exceptionally short and the piston hangs out of the bottom of the bore quite a bit. It looks a little scary, but they were trying to do the same thing, which was move the piston pin away from the top of the piston on a power adder especially nitrous, to keep the rings in the engine, make the engine live. But, so this is our block that we'll be doing. I got to finish notching all the cylinders. These sleeves in this block are 6 3/4 inches long, so they're actually longer than a big block, which is 6 1/4. I believe an SVO style block or a D9 style 460 block has a 6 1/4 inch long sleeve. So these blocks with this deck plate on them will be able to swing a 4 1/2 inch stroke. As we've mentioned before, we did move the cam. I don't have all the cam bearings in the block just yet. I'm just doing the mock-up and the grinding. But this is a 55 millimeter core. The aluminum rod clears it easily since we've moved the cam a little bit higher in the block. So I think this is going to turn out to be a very, very nice power adder combination. So we'll continue to grind on this, keep you posted, and show you some of the other stuff that we've been able to do on the car, and keep you posted on the progress, because we are probably only about 80 days away from first race. We hope we make it. See you next time. Thanks.